we are going to be looking at factoring that are some special cases. So what we need to do is we need to always look for what's called the greatest common factor. Is there a number in this problem that we need to factor that all of the terms have in common? Yes. All of these terms can be divided by 2. So what we're going to do is called factor out the 2. So if we divide by 2 or unmultiply that 2, what would be left? 4 would now be down to 2x squared. Minus 10 would now be down to 5x. And minus 6 would now be down to minus 3. Now that we've taken out that greatest common factor of 2, we continue to look at what's inside the parentheses. If there's still a squared in that problem, then it can probably be factored more. So now we go to the diamond and rectangle version of factoring. So we'll make our rectangle and diamond. We start with the 2x squared and the negative 3 in opposite corners of a diagonal. If we multiply those together, it makes negative 6x squared. And that's what we are going to put into our diamond problem, negative 6x squared. And then we use that middle term, the negative 5x, to go down in the bottom of our diamond problem. And we ask ourselves, what are 2 numbers that could multiply to negative 6 but add to negative 5? And it would be negative 6 and 1. And we put an x with both. Negative 6x plus 1x would make negative 5. And negative 6 times 1 would make negative 6. The 2 numbers we picked go into our diagonal on the rectangle. And now we just try to take out those common factors. 2x times x would make 2x squared. X times 1, 2x times minus 3. And then we use our rectangle. We've got 2x positive 1 as 1 dimension and x minus 3. And it looks like we've done factoring, but we can't forget that 2 greatest common factor we just put in front as a common factor. So our new factoring that I haven't read, if it all was multiplied by 2, it would take us back to the original problem. Always look for a greatest common factor before you start the rectangle and diamond. Here's another situation. 81 and 1 don't have a common number that I can divide them by or take out, but I noticed there's only 2 parts of the quadratic. It's missing the piece in the middle. So it can be easiest to rewrite it with that piece in the middle. 81m squared. There are 0 m's and then minus 1. Now I can see all 3 parts that I need to use for my diamond and rectangle to do the factoring. So we'll start with the 81m squared and the minus 1. If we multiply those together, we get negative 81m squared. And then we know that on the bottom of our diamond pattern, we need them to add to 0. The only way to add to 0 is if you have the same number, positive and negative. That would cancel each other out. And so to make 81, that would be a 9. 9m and negative 9m would multiply to 81, but add to 0. 9m, negative 9m. And then we look for those common factors. 81 is 9m times 9m. And we would have 9 times a minus 1 or a positive 1. And we can write our factoring. 9m minus 1 and 9m plus 1. So if you see a factoring with a piece missing, always assume to insert a 0 position there. Here's a few more special cases that you can try. If you notice part A, it's missing that middle piece. You'd have to add in a plus 0x. If you notice part B, it's missing that end piece of plus 0. Part C has what's called a greatest common factor. All the numbers can be divided by 2 first. And part D doesn't even have an x squared. So you don't need to do the diamond and rectangle if there's not an x squared. This is one where it's just what's called a greatest common factor. And same with B. Actually, B and D are both a greatest common factor. I'll do those ones for you. If I start with problem D, 40 and 100 can both be divided by 10, but that's not the greatest common factor. They can also both be divided by 20. So I'm going to take out a factor of 20. 20 times 2 would make 40, and minus 20 times 5 would make 100, so 5m. And I know that this factoring is finished if there's not a squared and the numbers 2 and 5 don't have anything else as a common factor. This is the final answer for this factoring problem. From greatest common factor, we could stop because there was no other common factor and there was no x squared. If we go up to problem B, this is a case of greatest common factor. 12 and 16 can both be divided by 4, and both terms have an x in them. So our greatest common factor is actually going to be 4 and x. So we're going to put a 4x outside the parentheses. 4x would need to be multiplied by 3x to get 12x squared, and 4x would need to be multiplied by negative 4 to make 16x. This is our final answer. You could have also done 12x squared minus 16x plus 0, taken out the common factor of 4, and done the diamond and rectangle. You would get the same answer. I will not do these last two. You're welcome to try taking out the greatest common factor by yourself or putting in the missing 0 term. Try factoring them and then pause the video. Then restart the video to check your answer.